Good day. I am Jay Manzano Marca, and I'm going to discuss the topics on the sixth week of our subject. Our topic is all about sampling distribution of the sample mean. So in sampling distribution, we have the expected value and standard error. The sampling distribution is a mean standard deviation. So we define that the expected value EV as the mean of sampling distribution and the standard error SE as the standard deviation of the sampling distribution. It turns out that for the sampling distribution of the mean, EV is a population mean. Thus, you can say that the sample mean is an unbiased estimate of the population mean. So let us have an example. Suppose you are interested in estimating the population average height, population average weight, and the population average body mass index of these 15 female learners by getting estimates based on the sample average height, sample average weight, and sample average body mass index of the two female learners selected at random. So this is the data on height, weight, and BMI for the 15 female learners, wherein the population average on height is 1.33, for weight is 48.2, and for BMI is 24. For the population standard deviation, for height is 0.195. For the weight, we have 6.988, and BMI is 9.357. So now, if we're going to draw a box of 15 tickets and mention that these tickets represent the 15 female learners, then ask learners how many possible samples of size of 2 can be obtained. So how many possible samples do you think? So we have, yes, it is 225. So 15 times 15, so we have 225 possible samples of size of 2. So here, we take a part of the 225 samples. So here, one of the combination is the student 4 and the student 12. So the student 4 and student 12 has the average height of 1.44, average weight of 45, and average BMI of 21.75. For the standard deviation, the sample standard deviation for the height is 0.269. For the weight, we have 11.314, and for the BMI, we have 0.118. Okay, so if we're going to take all of the 225 combinations, so with regard to the sampling distribution of the sample average height, the EV or the expected value may be readily calculated as the mean of all 225 sample average heights, or EV is equal to 1 over 225 times the sum of all the 225 sample average heights. Okay, so the expected value is 1.332, which is the population mean. Okay, so we can say that expected value is the population mean. So while the SE or the standard error, the standard deviation of the sample average height is SE is equal to the square root of 1 over 225 times the difference, the squared difference for each between the sample average heights and the sample mean. Okay, so we have roughly it is 0.14. Okay, so we can say that the value of SE is less than the population standard deviation of 0.195. Thus, you could say that the sample or the standard error is the ratio of the population sample standard deviation to the square root of the sample size, or S is equal to the sigma over square root of the sample exercise. So that is for the week 6 of our subject. So thank you.